Hello everyone. I am H.K.B. the Silva, and my colleague friend is Eheliyagoda. So we are going to talk about today an algorithmic approach for heart failure prediction. So first, we selected an appropriate data set for this task. Uh, Therefore, we searched many datasets in Kaggle website. So, and selected three datasets. Uh, the one is heart disease prediction dataset, and another one is heart disease classification dataset, and the third one is heart failure prediction dataset. So we named those as A, B, and C the, for our easiness. So when we analyzing these three data sets, we considered this kind of criteria. According to these criteria, we selected this key data set as the most appropriate one for our task, our prediction. Uh, you can see there are some explanations for that. So this heart failure prediction dataset T has 918 records. That's the highest number of records among these three datasets, and uh, the usability score is 10 in that data set. That usability score is generated by Kaggle site, and also in that data set the ranges are narrowed and readability is better than the other two. So that's why we selected this data set for our prediction. And yeah, this is our data set. This is the visual representation of our data set. There are several parameters like chest pain type, several important parameters like chest pain type, resting BP, cholesterol, fasting BS, and so on. And there are 919 data, and yeah, this is the describing and pre-processing phase of our data set. So we in this we generated these diagrams, these graphs, bar charts and pie charts. So uh, in this pie charts and bar charts, we visualize the comparison between the parameters of our data set. As an example, you can see here uh, this pie chart shows the chest pain type of people with no heart diseases. And you can see here the chest pain types between the chest pain types of people with heart diseases. So the comparison between these two facts actually, and also these one these pie charts and these bar charts shows the same representations. So we included those in our report actually, and here are the same thing. You can see this is cholesterol uh, quantities of our data set with people have no people with no heart diseases, and here uh, the cholesterol quantities of people have people with heart diseases. So say these all are the comparisons actually. So then we selected uh, learning method, a machine learning method, and uh, two models for this our task actually. So we selected supervised learning, and in supervised learning we selected uh, random forest classifier model and the logistic regression model. So the reason is we selecting the random forest classifier model. Uh, it's an interesting. It provides a great balance of predictive power, robustness, feature importance analysis, and uh, dealing with skewed data, which actually makes it a very interesting option for the heart failure prediction model. So using that random forest in our approach, uh, it will balance the accuracy and reliability. And so the insensible nature of this random forest classifier involving multiple decision trees that makes it all the more predictive and reduces overfitting risk. So additionally, this ML model allows us to perform feature importance analysis, and therefore we can identify which factors will most contribute to heart failure risks, and thus help in understanding the disease process, providing a guide for further research. So then we selected logistic regression model as the other model because that model is an interpretable, transparent, and effective mechanism that also serves as a good baseline. Therefore, logistic regression becomes an attractive choice for solving our problem of predicting heart failure. So, the inclusion of logistic regression in our methodology will extend the aim from attaining an accurate and transparent model of heart failure prediction to making the model understandable, which was our aim in order to make well-informed decisions on heart failure. So now I'm going to invite my colleague Rohindu Eheliyagoda to continue the rest part of our presentation. Thank
Yeah.
you.
Yeah. Thank you, Shanta. So I'm Ravi Eheliyagoda. I'll continue the presentation. So in that methodology, so first important necessary. Yeah. So first we important the main libraries and models. So it's actually a common thing in ML model training. So we imported random forest classifier and also the model logistic regression model. So next we splitted the data set into the test and train. So it's also the initial thing in ML model training. So we did that. Uh, next. Next, logistic regression model. The first we can show you. It's showing the first graph. It's showing classification report, and down we can see confusion matrix, and also the other one is the trade-off visualization between the true positive and false positive. Next slide. Yeah, the random forest classification model. The first we can show same classification report, and below confusion metrics, and also the one is trade-off visualization between the true positive and false positive. Actually, let's describe it in detail between details in the results and discussion section. So in that results, the results of logistic regression model. So model performs well with the only a small number of errors, like two false positive and three false negative. So out of 92 total instance, it accurately classified 27, resulting in high accuracy. 27 means 35 true negative and 52 true positives. So the confusion matrix complement the classification report by showing the exact number of correct and incorrect predictions. So next, results of the random forest classifier model. So in there, out of 22 total instance, the model correctly classified 88 instance, with only four misclassification classifications. So 88 instance means 35 true negatives plus 53 true positives. And also the misclassifications for misclassification models mean two false positive and two false negative. So in high number of correct predictions and low error rate indicate that the random forest classifier is highly effective at predicting heart diseases in this dataset with normal minimal errors in both directions, like false positive and false negative. So next, yeah, I'll explain the contribution of the report. So dataset, we both did the dataset. Uh, so random forest classification model did my colleague Prashant D. Silva, and logistic regression model did myself. I'm Rohidu Eheliyagoda. So next, those are the references we have, and yeah, thank you so much for our presentation. Thank you.